Welcome to Percent Applications. Today we're going to be looking at several ways that percents are used and some various calculations. And these are things that you are likely to see in your everyday life. So first we're going to take a look at commissions. So let's say that the most wonderful thing happened and Mrs. Six won some money in the Mega Millions. She decided to invest it to make more money. She won $250,000. The person at the money management company charges a 7% fee of the initial amount invested for their services. How much money does Mrs. Six need to pay this person? There's multiple ways that we can set this problem up. For this problem, though, we're going to use a very basic equation, percent equation. So we're going to take the $250,000, and this is our initial amount. We are going to change our 7% to a decimal. What is the decimal form of 7%? Well, percents are out of 100, so that is going to be 7 hundredths or 0.07. We're going to multiply times our percent as a decimal. And when we do that, we find that 7% is going to be $17,500. So Mrs. Six has to pay $17,500 to the money management company from her winnings, with the idea being that they're going to invest the money and Mrs. Six will make all this money back plus more. So let's look at how much money does that leave Mrs. Six to actually invest. How would I figure that out? Well, I'm going to subtract. So we'll take that $250,000 and subtract the $17,500. So this is our winnings. And we're subtracting out the commission paid. So this is a commission. So Mrs. Six will be left with $232,500 to spend. So this is called a percent equation. So we're using equations here. Now we're going to take a look at simple interest. So the money that was won up here is going into an account that's going to earn 2% interest per month. We want to know how much will this money have earned in 1 year and 2 years, and how much then is in the account. So we can use the interest equation, and that says that principal times rate times time equals the amount of interest earned. So this is the shortened version of the equation. So principal, and this is money, times the rate. This is going to be your percent, times the time. So the time may vary. That could be months, it could be years. It depends on how this percent is paid out. Is going to equal your interest earned. All right, so let's see what that would be. So we found out that Mrs. Six has the $232,500 is the amount that is going to be invested after paying for this person to take care of that money. So we'll take our $232,500. We're multiplying it by 2%, which we have to write as a decimal. That's going to be 2/100ths, just like we did up here with the 7%. And this is being paid out. We want to look after 1 year. And notice that this says per month. So this is a 2% per month. So if we're looking at 1 year, that is 12 months. If we want to look at 2 years, we can take this, well actually we'll do that something different in a second. So let's see how much we have here. And this is going to earn $55,800 in 1 year. So this is interest earned in 1 year. Well, that's a pretty good amount. So this is the original after the commission. And this is our rate. This is our months. Notice that I'm attending to precision and labeling what all of these mean. All right, so now if I wanted to find out the amount in 2 years, I have a couple options. I could change this to 24 months. I could double this amount. Any of those would be fine. So let's just go ahead and, now the way interest actually works is there's compound interest, but we're just looking at simple interest, okay? So we'll just go ahead and change this to 24 months. So we'll look at our 232,500 times 2% times 24 months. And that's going to give us $111,600. So that's the amount earned. Now, I want to double check to make sure that these two confirm, because remember we said we could also multiply this by 2. So if I take 55,800 and multiply it by 2, I want to double check that I do indeed get a 111,600, and I do. So either one of those ways would work. Now, I need to figure out, well, how much money does that mean I have? So let's just, we'll call this area over here the new balance. So we take our original amount, 232,500, and we're going to add the 55,800 that we just earned. And our account now has $288,300. So we've more than made up for what we had to spend up here in the commission. So, and I just realized here I have an extra 0. So I need to fix that. Luckily, I looked back at my work and found that extra 0 sitting there. So let's take that extra 0 off because that would not be correct. It's 17,500. Okay, there we go. Now it is more accurate. But again, I paid 17,500. That's okay because I just made a lot more. To determine the 2 year, I can say 232,500 plus 2 times 55,800. Or I could just add this. Either one would be fine. And my new balance is going to be $344,100. So that is using the percent or the interest formula. So that is a formula that you do need to know. That's the interest formula. All right, markup and profit. So Katie is a pastry chef. She sells pastries for the holidays. She's making chocolate croissants. The cost of the ingredients to her is $23.50. She wants to charge $40 for the batch. How much is she profiting? And what is the percent of markup to the customer? So first we want to figure out how much is she profiting. So if she's going to charge $40 to her customers, we want to take out the cost of supplies. And when we subtract those, we get that for every order, she is profiting $16.50 on each order. Now, we want to figure out, well, what percent is she marking up the cost to her customers? So in order to do that, the first thing that we actually have to do is determine the percent of change, or determine the amount of change, which in this case is $16.50. So that is our amount of change. Then we're going to take that $16.50 and we are going to divide it by the original cost. So this is the change divided by the original. And we find that when we do that, she is marking up the cost 70%. So this is 0.702. So we have a 70% markup in price. Okay. And we can kind of tell that because we can see that this $40 that she's charging is not quite double the cost to her. If it was double, then that would be 100% markup. Let's look at the next one. So now we're looking at some everyday uses for percent. And that is calculating your tax, your tip, those sorts of everyday necessities. So first thing we need to do is calculate the subtotal for this receipt from Carrabba's. So if we add up the items, we get that our subtotal of our items is going to be $40.26. And we got that by adding $14.79 plus $11.99 plus $5.49 plus $7.99. When we add all of those, we get a total of $40.26. So the next thing we're going to do is actually jump down here to the tip. So the amount that you give in tip is based off of your subtotal. So in this case, we had great service. We want to leave a 25% tip, and that's going to be based off of this $40.26. So we're going to take our $40.26, which is our subtotal, and multiply it by the amount that we want to give in tip. And we get $10.07. So we're going to tip this person $10.07. Our tax is also based on the subtotal. So each of these items are based on this. So for the tax, we're going to do, again, the $40.26. So this is our subtotal. We're multiplying it by 6% tax, that is sales tax in the state of Maryland. So our $40.26 times 6% as a decimal gives us $2.42 in tax. So I'm going to write that right here. Now to find my grand total, I'm going to add my $40.26 plus my $10.07 plus my $2.42, and I get a grand total of $52.75 that I'm spending. And again, I'm using the basic equation strategy for doing these calculations. Next, we're going to take a look at figuring out how much something has been discounted. So this is the opposite of our pastry chef problem where the item was being marked up. Now we're taking a look at how much it's being discounted for. So the first thing that we need to do is find our difference. And we're going to put our difference divided by the original. So I'm going to subtract them, $14.99 minus $10.99. It doesn't matter which number comes first. We only want the positive result. So always do bigger minus smaller. But in terms of original, that's where it gets a little bit trickier, and you're going to have to attend to precision and read your information carefully. So our original amount in this case is $14.99. All right, so you're going to always subtract bigger and smaller, but our original price goes at the bottom. So I have a difference of $4 when I do $14.99 minus $10.99. I have a difference of $4, and I'm dividing that by my original price of $14.99. That gets me a decimal of 266 thousandths, which is about a 27% decrease in cost. So using this same strategy, we can now look at this next problem, which is about a markup. And for this one, we're going to look at using a slightly different strategy. The other strategies that we use will work as well, but I would like to look at using a ratio table for this problem. Corey is a photographer. She prints pictures and it costs her $3.50. She wants to make a 450% profit. How much does she need to charge for the pictures? So we're going to actually make a table for this one. And this table is going to have 3 lines. We're going to have the percent, the profit, and how much she's charging the customer. So if she's going to make a 0% profit, or if she's going to charge the customer nothing, she loses $3.50. So if she were to give the picture away for free, she loses $3.50. So this just gives us a base. Now, if she were to make no profit and break even, she's going to charge the customer $3.50. So she's giving it to them at cost. They are paying the cost. If she wanted to make a 50% profit, she's going to make a profit of $1.75. That's 50% of $3.50. And that's going to be added on to the cost to the customer. So that gives us a total of $5.25 that she's going to charge the person. So she's going to charge them $5.25. They're paying $1.75 extra, which goes in her pocket. So that's 50%. Let's look at 100%. At 100% profit, she's going to charge them she wants to make $3.50. It costs $3.50, so she's going to charge them $7. And that's a 100% profit. All right, what if she wants to do a 200% profit? She's going to charge them, so we can double this. 200% profit, she's going to charge them the profit $7, which means that she's going to charge them $10.50 because it costs $3.50 to make. So the $3.50 plus the $7, she's going to charge them $10.50. Well, and what we're trying to do here is build up to 450%. So now let's look at 300%. At 300%, she needs to charge an extra $10.50 on top of the $3.50, and she's going to charge them $14. And she makes $10.50 profit. Well, now we're at our 400%. At 400%, she's going to charge an additional $14 over the $3.50 cost. So the customer has to pay $17.50. Just fix that. Our question asks us for $4.50. So how can we show that $4.50? Well, the great thing about a ratio table is we can actually add pieces. So we can add this 50% that we found earlier, the 400% that we just found, and together those can give us our 450% when we add them. So 450%, if we add our $175 and our $14, she has to charge the people an extra $15.75. We're going to add $5.25 and $17.50, and $5.75 and $17.50 give us $23.25. So she needs to charge them $23.25 in order to make a profit. We could also use our other strategies as well. So making an equation would also work. All right, questions on that? If you have any questions, go ahead and write them down. And I am seeing, I believe I made an error. And that error is I have double used the 350. So let me just fix that. Because the 350 of the original cost has been built into both of these, so I just charged it twice. So we can add our percents, add these two, because these don't include our 350, to get our 1575, and then we add the 350, sorry about that, and we get 1925. So the parts that we can add together are what the actual percents were. So 50% plus 400% is 450. $1.75 plus 14 is $15.75 plus the $3.50 that it costs, which was 0, and that gives us $19.25. Alternative strategies. Is we could have just said the $3.50 times 4.5, and that is what 450% is as a decimal. And when I multiply those, that gives me $15.75 for the profit, and the $15.75 has to be added to that cost of $3.50, and that gets you the $19.25 that she has to charge her customer. All right. Lastly, Mrs. Six's son loves Thomas the Tank Engine. She was looking to buy some Thomas toys. The train table sells for $250. The trains are about $14.99 each, give or take, and track sets are $32.99. Mrs. Six needs to buy 5 trains, 1 track set, and 1 table, and she has a coupon that gives her 10% off her total purchase. So let's see how much I'm going to save using the coupon. So the first thing I need to do is find out my total cost. So I'm going to buy a train table. That's $250. I'm going to be buying 5 trains. So that's going to be 5 times $14.99. So this is our table. This is our trains. And 1 track set, which is $32.99. Well, order of operations says that I need to multiply before I add. So I'm going to multiply this to find that I'm going to spend a total of $74.95 in just the trains. So now I can add my $250 for the train table and my $32.99 for the tracks. And I get a total of $357.94. But I have a coupon, and I definitely want to use this coupon. So I can say $357.94 and multiply it by that 10%. And when I do that, I'm going to get $35.79 savings. So that is my savings. But that is not what I'm going to pay. I still need to find out what my new total would be. So I can take my $357.94 and subtract the $35.79. And when I do that, I get a total of $322.15. So this is my total. But now I found a 20% off coupon. And I can get 20% off 1 item in addition to my 10% off coupon. So what would make the most sense? What would be the place that I would want to spend that 20% off coupon? Well, I want to use it on the table because that's the one that costs the most. So I'm going to save the most money. So the first thing I want to do is take that table cost and multiply by the 20%. Or actually, you know what? Let's use a different strategy. We've been using this equation the whole time. Let's look at another strategy that we can use. And the other strategy that we can use is actually setting up a proportion. That we want to find what 20% of 100 is going to be. Or 20% of 100, and we want 20% of $250. So now I can cross multiply. And so I get 100x, and then I'm going to do 20 times 250, which gives me 5,000. And I'm going to divide that by 100. And I get that, so I'm dividing here. And I get that I'm going to save $50. That's a significant savings. So now I can do, I'm going to take, so my 250 minus 50 is going to be $200. This is the cost of the table, my new cost of the table. So I can now take $200 plus the $74.95 that we know we're going to spend on the trains, plus $32.99. So that's going to give us a total of $307.94. Now, alternatively, once I figured out that this was a $50 savings, I could have just subtracted $50 from here. As you can see, this and this, it's just $50 less. But that's a second way to confirm. So I got my answer here. I can confirm by saying, oh, look, that's $50 less. So now I can take my $307.94, and I want to find what 10% off of it is. So let's actually use the same strategy, but let's flip it around and look at it another way. If I'm getting a 10% discount, that means that I'm going to pay 90% of the original cost. So I can say X over 307.94 equals 90% out of 100. And by doing this, I don't have to do subtraction. I'm not going to have to subtract my answer from $307.94. It will just tell me what my new amount is. So that is another strategy you can use as long as you know what you're doing here. So 100x equals, so when I multiply 90 and $307.94, whoops, I multiplied it wrong. I get that I will be paying $277.15. Oh, I wrote that wrong. Wait a second. No, I did have it right the first time. Sorry. Well, that's what I will be paying. But when I multiply, sorry about that. When I multiply, I get to $27,714 or excuse me, I'm just multiplying here. $27,714 and 6/10. Whew, let's try that again. Now I divide that by my 100 and I get my $277.15 that I'm going to actually pay. All right, so you've seen 3 different strategies that you can use throughout these notes for dealing with percents. You can set up proportions. So if you're trying to find an amount off, you can either set it up as finding out what that amount off is going to be and subtract it from your original, or you can flip it around and find out what your new amount is going to be by looking at the opposite. We have set up equations where we're multiplying by the decimal form of our percent. And then on the previous page, we set up ratio tables, where once we found out various percents, we can add across in our ratio table. Please check on the Google Classroom for your next steps.